Hello, I wanted to talk to you today about troubleshooting in regards to reference ground, to reference ground and what that looks like. So I've identified a circuit here that we have, and as you look at this circuit here, we've got several things to look at. We've got our ground, which is the negative part of the power supply in this case, and we have test points A, B, C, and D, as you see here, from A to ground, B to ground, C to ground, D to ground, and then ground. And those normal readings are going to be 30, 25.6, 16.5, and then basically 5.4 here. And that's what we're looking at as normal readings. So when I'm reading at point A, I'm reading these 4 resistors. The point B, I'm reading the bottom 3, and point C, I'm reading the bottom 2, and point D, I'm reading the bottom 2. So what I've done is I've laid out several different situations. If I were to hook this up and do maybe what I would call a black box test, where all I had were the actual voltage readings from this deal. So I've got 8 different examples here. If we look at example 1, we say that at test point A we're reading 30 volts, test point B we're reading 23 volts, test point C and test point D are 8.44 and 8.44 volts. If I look at that, I see that my readings are not what normal is. So my reading between C and D don't change. So that would indicate that there is a sharp between D and C, or between D and ground. Or, there's no change between D and C, which means there's a short there, just like there was a wire placed across R3. So in example 1, that would be R3 is shorted. In the second example, you see that there's no change between A and B, but there is a change between B and C and D. So my voltage is changing at points B, C, and D. It indicates that my circuit is operational, but between points A and B is that there is no change. So that would mean that there is a short on R1 in example 2. In example 3, we have 30 volts, 30 volts, 30 volts, 30 volts. And then I know just by definition is that when I read voltage at ground, it's going to be 0. So all my voltage is between D and ground. This would indicate that have all the voltage at D and none of it at ground. That would indicate that R4 is open. And then example E is I show that I have voltage drops that are changing. There is not a change between points B and C. That would indicate that if there's no change between B and C, but there is a change at points A and B and D, is that I would have a short between B and C. So that's how those look. And then I've got the answers to these written upside down, so you can go ahead and do those bottom 4s, example 4 through 8 yourself. Just take a look and see how you do on those. And if I was in the lab, this is how I would set this up. Is I would have my voltmeter, and I would be reading volts. And the way this is set up, my power supply is set up. Let's say I have a black box here, and I've got labeled here A, B, C, and D on my black box. And I would take the positive end of the power supply and put it at point A. The negative end of the power supply would go at ground. And then the negative end from my meter, this ground from or common from my meter, would go there. And the only probe that is moving is going to be from my voltmeter. So you can read I have VA, VB, VC, and VD indicated here. And that's the readings I would be taking on this black box, A, B, C, D. If you happen to be taking one of my labs, and we'll do this in laboratory and actually duplicate this experiment, your values will be different. I've changed those values, but your values will be different. In this way, this gives you an opportunity to actually sit down and put the circuit together to measure the black box and then do some analysis of what's wrong. So hopefully this will help out, and look forward to seeing you soon.